I'm Anil Kumar, and here is an excellent question on sketching rational functions. The question is, determine the intercepts, holes, and equations of all asymptotes with behavior of y equals to x cubed minus 2x squared minus x minus 2 divided by x squared minus x minus 6. Then sketch. So let us analyze our function. It's a rational function, ratio of two polynomials, x cubed minus 2x squared minus x minus 2 divided by x squared minus x minus 6. So what do you note here? Now we see that the degree of, so whenever you get rational functions, first try to analyze. So we see degree of numerator is higher, right? Degree of numerator is equals to 1 plus degree of denominator. Is that okay? So that means what? That means oblique asymptote. Is that okay? Oblique asymptote. So that is the first thing you get. Second, you could now factor numerator and denominator and figure out about the zeros, holes, vertical asymptotes, and so on. Now this is a cubic equation. To factor, well, like to only possible factors are, you substitute for the numerator p of we can try it out. Find what is p of 1, what is p of minus 1, what is p of 2, and what is p of minus 2. Now when you do all that, you'll find that they are not equal to 0. So it is not so easy to factor the numerator. However, the denominator can be factored very easily. So we have denominator which is x squared minus x minus 6, and product we need minus 6, sum as minus 1. So that could be factored as x minus 3 times x plus 2. So that is the denominator factor, correct? So that definitely gives us at least two vertical asymptotes, correct? So let me write this equation once like this also, which is x, or let me not do that. Okay, doesn't matter now. Minus 2x squared minus x minus 2 divided by both these factors, x plus 2. So from here, what do we get? Actually, I want to leave this space for sketching the graph, so I'm not writing a lot. Okay, but anyway, we get here two vertical asymptotes. Let me write down small place. So I'll write in between. Good job. So we will say that gives us two vertical asymptotes, right? So we get vertical asymptotes, and the vertical asymptotes are at x equals to 3 and at x equals to minus 2. I hope you don't mind my squeezing in so many things here, right? Since this space I want to keep for my graph, right? I don't have a graph paper to work with, but I'll try to make a good one by hand. Now how to find the oblique asymptote? So for that we have to do long division. So let's do long division here. Okay. What do we have? We have x cubed minus 2x squared minus x minus 2 divided by, don't write in factor form, write original thing, right? X squared minus x minus 6. Now that goes x times, okay, x times. So we get x cubed minus x squared minus 6x, and when you take away, you get this minus this is minus x squared, correct? And here we get plus 5x. Now we can do it minus 1. So if I write minus 1, I get let me bring down 2. Okay, minus 1 makes it minus x squared plus x, and this would be plus 6. And when you take it, you get some remainder, right? And the remainder will be 4x minus 8. So remainder is 4x minus 8, which is positive, correct? But what you get from here is that the oblique asymptote equation is x minus 1, right? So let me now write oblique asymptote is what? So we get y equals to x minus 1 is our oblique asymptote. So when I say oblique asymptote is x minus 1, that means y-intercept is minus 1 and slope is 1. So I'll just sketch a line like this. Now this is y equals to x minus 1. This is my oblique asymptote, not related with this function, right? But our function is approaching this line. How does it approach it? Let us check that. So you could write this equation as x minus 1. Okay, I think now I will use some space here. So what we have here is y equals to, I could write all this as x minus 1 plus the denominator, which is 4x minus 8 divided by the quadratic equation, right? Which is, let me write in factored form now. X minus 3 times x plus 2. So it is our choice, we take this. So we'll sketch this equation, correct? So if x is very large, in that case we have something positive. So what happens? So that means we are approaching the oblique asymptote from above, right? So we are approaching from this side. Do you see that part? That is the behavior near the asymptote. However, if x is negatively large, so this part is x squared, this will always be positive, right? So if I say very large negative value, this part is positive. However, the negative will make this negative. So that means lower than x minus 1. So we are approaching from this side. Do you see that? So that is kind of behavior. So now we have understood how the function behaves near infinity, that is end behavior, positive and negative infinity. It is approaching the line x minus 1. As x approaches positive infinity, it is approaching the line from above side, and when x approaches negative infinity, it is approaching from lower side. Let's sketch our vertical asymptotes, which are at x equals to 3 and minus 2, right? So let 3 and minus 2. Since this line is x minus 1, if I put this as 0, this point should be 1, right? So this is 1. Anyway, so now what we are going to do is, we are going to sketch our vertical asymptote. 3 will be kind of here. So let me just sketch approximately one vertical asymptote, which is at 3. And the other one at 2. Okay, let's say this is our 2. Okay, so that is the 2. So we have these two vertical asymptotes. This one is at minus 2 and this one is at 3. That point is 1 for us. This point is minus 1. So these are some of our points. So now we know that the graph of the function is approaching here. What you should do is, you should see the behavior near the vertical asymptotes, correct? So if I have a value which is close to 3 but less than 3 on this side, let's say 2.9, in that case, that this will be positive, and here 2.9 will be negative. Negative times positive will be negative. So we get negative value, right? So, and then you should calculate this value and figure it out whether this value is negatively high or positively high. So you need to calculate some values to figure it out and then find what the value is. So you have to test here. So when you test 2.9, you find negative, right? So that means you are approaching negative value. Is that okay? Kind of like this. Here, if you take a value which is more than 3, then this is positive, correct? Since this is positive, everything here is positive, you are approaching this side, correct? So that is how it is. Now you have to analyze near minus 2. So when you take a value which is 1.9 minus, in that case you will observe, since we take minus 1.9, in that case you will observe that you have a positively high value. So it approaches in this direction. So you do all those calculations. I'm only teaching you a method of doing it, correct? Now, so that is how it is. And then we should also find x and y intercepts. If I place, let me write f of 0, x-intercept will be, when I place x equals to 0, I get minus 2 over minus 6, which is equals to plus 1 over 3. So x-intercept, when, I should say y-intercept, x equals to 0, is plus 2 over 3. So we are very close here, kind of this place. So we have, the y-intercept. To find the x-intercept, we have to see when the numerator is 0. That is kind of a difficult thing. So you may at times leave it, correct? But from the behavior, what we have understood is that the graph is approaching. Now let's take behavior at this place also. On the positive side of minus 2. So if it is, the negative side of minus 2, if I substitute a value which is minus 2.1, so check the values for x equals to, I should say, minus 2.1, right? Check the value for minus 1.9. So that gives you behavior near these 2 points. Then also check the value at 2.9, that is close to 3, and at 3.1 to get these values. So you will understand that the behavior of the curve is approaching like this, and here if you take a value, it approaches in this direction. And knowing these values, y values, use your calculator, find these values, you can sketch your graph. The graph of this function will then look like, let me sketch with another ink. So it is approaching here, so it will be kind of going like this. You see that? Like this. On this side, it is kind of like this. Correct? And here, it will be going like this. Right. So that is going to be the graph of the given function. And how do you find it? You find it by placing different values of x. And then you get some more points, right? So 1 point, very good, is also x equals to 1. So just place x equals to 1, calculate. So place, and then you'll get few points. Once you get few points, connect them. Do you understand? Connect them. And you will get a graph like this. So let us review how to solve or how to graph such rational functions. First thing here is calculate the oblique asymptote. So in this case, first step should be, let me write them down here in series. Oblique asymptote. That is, we found by division. The quotient is your oblique asymptote. Then identify vertical asymptotes, and behavior near asymptotes, Correct? So also near these two asymptotes. Once you find behavior, you have 100%, very close to 100% of the graph done. Now to give the actual shape to the graph, evaluate points. Value at some points. Now when I say some points, these are good points to take. So you could take 1, -1, right? 1, -1, half, and 2, kind of, right? So you just take few points and then you get the intricacies of the graph. You do not have to take points in this region. It's very clear, right? In these regions, but take some points in this region between -2 and 3 to get actually this graph. So that is how you're going to sketch a rational function given to us. It is a very important question from test point of view. Go through it nicely, sketch and practice. Thank you and all the best.